Hello everyone, this is Alan again, aka Chita, and today I bring you the second video on my series of the COMP1 pre-release analysis. Alright, now last video I mentioned that I wanted to make a second video on variables, the role of variables, and although I will make a video about it eventually, maybe the next video, maybe not, today I thought of doing a slightly different video. It was the sort of like the idea of my computing teacher. My computer teacher mentioned, sort of gave us a homework of thinking on a way of implementing a way for the user to play the game with 2 decks instead of 1. Now, I said it was sort of like her idea because I made it one step further. I actually made it in a way that the user can choose how many decks they will play with. I made it so the user can choose any number between 1 and 255 decks to be used, and the reason for that is that I'll make a variable to store the number of decks, and I will make it as a byte, and as we all know, a byte can be any number between 0 and 255. Now, let me just add the variable here. Then I'll call it decks on the plural because we already have this variable over here called deck, as byte. And as always, we'll add our comment. Alright, now this variable we're going to use to hold the number of decks that will be used. Now immediately what some of you are already thinking of is the limit of this array. Now I could have made 104 to allow for 2 decks, or I could have made as many, however much it would take to hold 255 and make this as the limit of the array, and then ignore all the values I'm not using. But I'm not going to do that because that'll be a huge waste of space. What I'm going to do is I'm simply going to delete this for now, and then we're going to redim this array to set the actual size once we have this filled in. Alright, now we need to create a way to fill in this variable. Now to do that, we'll make a new function. Now we're going to go all the way to the bottom, and I'm going to make function get number of decks as byte. Alright, now I will handle the validation for the number, because as I said, that byte can be any number between 0 to 255, and it will work perfectly for any number within this range, with the only exception of 0, because if the user decided they want to play with 0 cards, then we're going to have a problem, 0 decks, because if the user decides they want to play with 0 decks, then we're going to have a problem because there won't be any cards to be checked, and that would bug the program. So I'm going to handle the validation for this to make sure that it will be a number, and it will be a number within this range, and it will be at least one or more. So first of all, let's make a temporary variable. I'll call it number of decks as byte. And now we are going to print in console.writeLine please enter the number of decks to be used, and then we're going to explain to the user from 1 to 255. There we go. Just capitalize this F. Next, we're going to take this and we're going to say that equal to, oh sorry, before we do that actually, let's make sure that if the user enters a letter instead of a number, it won't bug the problem. So let's use a try catch. So what we're going to do is number of decks is equal console.readline, and then we're going to check if number of decks is equal 0, and we make this number of decks is equal 1, and we're going to inform the user console.writeLine error, you not play with 0 text. 1 deck will be used instead. Then we're going to pause the program, as that is the procedure that we've created on the last video. Excuse me. So we are going to tell the user that you cannot play with 0 decks. We're going to pause so they can read the message nicely, and we're going to make the number of decks 1. Now if the user enters something that's not a valid number, or if it is a number greater than 255, it will also be catching an exception. We will say inform the user of the problem first, so .writeLine invalid number of decks, 1 deck will be used. Now I could have made in a loop, so if the user enters something valid you go back and do it again, but I'm just trying to save some time. You can probably figure this out by yourselves later. So number of decks is equal 1, and that is enough for the try catch. And now all that's left to do is to actually return this value. Return number of decks, and this function now is completed. Now let me just change this comment to the usual added. Don't know what happened there. And let's go back to the main program. Alright, now we've created this variable and we've created a way to fill this in. Now all that's left to do is actually fill it in. So before we load the program, all we're going to do is to make decks is equal get number of decks. Alright, now that we know the number of decks, we can actually redeem the variable, the array that stores the actual deck before we load it. So if you're not familiar with redeem, it's a tool on VP that allows you to handle the size of dynamic arrays. Dynamic arrays means that they will change their limits, so you can actually set the number, the maximum size of the array, the maximum index. Like you can change this number. So deck, and now this number will be 52. I'm sure we don't need this extra one. 52 times decks, and then we'll load the deck and we'll shuffle it, and there we go. Now we're going to do the same thing for option 2, because if you remember from last time, option 1 and option 2 are the same thing, except that in option 1 you shuffle the deck before you actually play the game. So pretty much everything that we do for option 1 we would have to do for option 2 as well. Alright, next up, load the deck. We need to make some changes over there. if you remember, click on the name of the function, and F12 takes you immediately there. Now, first of all, the way that we programmed so far, there's no way for this procedure to know how many DACs have been used, which will change the number of loads that we'll have to do. So what I'm going to do is I'm going to create another parameter here, and I'm going to say by vol, because we don't need to save, number of X as byte. And yeah, that will make 2 errors that we'll fix afterwards. But first of all, we want to come here, right under the declaration of the variable, not the count variable. We're going to make for I for index is equal 1 to number of DACs minus 1. We'll do all of that. Place it in there. Okay, now let me talk you through what's going on. We're not finished here, by the way, but just so you understand what we're doing. This means that we'll loop, if number of DACs is 1, we'll loop it once. We'll go through all of this code once. If number of DACs is 2, we'll go through 2 times, for 0 and for 1. It is very important that it's from 0 to number of DACs minus 1, because of what we're going to do next. Next stage is here. This will be plus, open and close brackets, 52 times I, and the same thing here, plus open 52 times I, close. Okay, now as I said, it's very important that you start from 0, because for the first time the 0 will take care of this. It will make it 0, so you're adding 0, you're not making any difference. And then you loop through the whole DAC once. Then if you have 2 DACs, you're going to want to loop through the whole DAC again one more time. So 52 times 1 will give you 52, so you're going to be whichever number on this current DAC plus 52 to take it to the second DAC. And this will work indefinitely for as many times as many DACs as you need to load. Now we're loading from the same text file. If you had a different text file, you could make it at once, or you could simply, I don't know, make a function, a loop, an embedded loop that will go through 1 to 0 to 3 for the cert, and then 1 to 52 for the rank, and you have unshuffled, everything in order DAC. But you know, I just wanted to use the same text file to load the new DAC, or all the new DACs. Alright, hope I'm not losing it. Let's go back. So over here, that's the first problem. We need to add the number of DACs. We call it DACs. That's really a mistake. I should have been making it a bit more consistent. Maybe number of DACs everywhere, or just DACs everywhere. Might be something that you want to do so you don't get confused. I'm just too late on the code to change it now. I just realized that. Alright, so we'll load the DAC and then we'll shuffle it. Now let's make sure that we don't need to do anything on shuffle, and as a matter of fact we do. Now 1,000 times, I still think it would still be a good enough number for a 1, maybe 2, but we are giving the user the option of playing with 255 DACs. 255 times 52, because that will be the number of cards, will be a lot less than 1,000. So you might want to increase this depending on the number of the number of DACs that you're using. So that's what I will do first. Again, by val number of DACs as byte. Again, we've made a few extra problems over there. We'll take a look into that in a second. So if 1,000 was good enough for one DAC, 1000 will be good enough for each deck that we're going to use, so we'll simply times it by the number of decks that we're using. And over here we wanted to change that because that's our upper boundary. So what we're going to do is that open and close over here, and that times the number of decks, and again over here times the number of decks. Alright, so now we're generating a random number between 1 and however many cards we have on our deck. This number will change, and we'll do that twice, and we'll change these two cards around, and we'll do that 1000 times the number of decks that we're using. So we're shuffling pretty much all of our decks 1000 times, each one of them. Not necessarily it won't necessarily be one deck shuffle 1000 times then you go to the next deck. It could be you just go all over the place, which is actually a good thing because we want it well shuffled. Now decks, so it doesn't bug. And okay, shuffle is done. Now let's go for the play game, which will most certainly have to make it some changes. Now you probably already spotted the pattern by val, number of decks as byte. Okay, what do we need to do now? Excuse me again, don't know what's going on with my throat today. First of all, over here we don't have any problems, over here we don't have any problems, and we go to the actual loop. This is the first thing that we're going to have to change. 52 times number of decks. Nope, wrong one. Now get card, that'll be just the position, the next card, and that'll be fine. Choice, it'll be the same thing, loop until, yeah. Display next card, no problem. Number of card plus 1, no problem. Over here it's pretty much everything done. Then we can go to the actual end of the game. What happens at the end of the game? First of all, number of cards turned over, it will still go all the way up to however much we need to go. The problem will be on these, actually within these two subs, that we're going to have to change. So let's go there. 51, that's going to have to change. What we're going to do is that 52 times, and I've forgotten to add it here, so let's go by val number of, I'm going to make at least this consistent, number of decks as byte. Now this times number of decks, all of it minus 1. Don't forget to put your brackets. This is one of the times that it actually makes a difference. Now if you manage to get a perfect game, so you guessed all of the cards, so 52 times the number of decks minus the first one that was given to you, then they're going to say, wow, you got a perfect game. If you didn't, but you managed to get 51 cards right, and you were playing with, let's say, 2-3 decks, then it wouldn't be a perfect game, you would be just a perfect deck. So that's what we had to change. Now let's go back to play game, under, and update recent score. Let's have a look if we need to do anything over here. Okay, update recent score. We don't need to make any changes over on the player name because the player name will still be found space. Let's just define the actual space. So in fact we won't actually have to make any difference in here. That's the first time, the first sub that we go through that we don't actually need to change anything. So here we go. Let's make this small change over here. Number of decks many numbers over here, and number of decks. Now another thing that we'll have to change, this. We'll do the same thing. Let's make open close, and we got 52 times number of decks, all of it -1. Done. Hope I didn't lose you yet. Let's have a try, shall we? Actually, before, let's just make sure that I added everything I needed to. Oh, not yet. That would be a problem. Here's just decks, isn't it? That's where I changed. Decks. Don't know why I didn't call number of decks and over there as well. Anyway, we don't have any errors or warnings, so let's have a look. It's actually the first time that I run the program. I haven't tried it yet, so hopefully it will work. So we went to option 1, enter a number between 1 and 255. So let's try 1 first, because this shouldn't make any difference for the actual game. See if it works. Okay, it works just fine. Let's quit the game and try again with a different number. Option 1. Oop, I forgot. Sorry, my bad. I pressed enter. I forgot that I added that. Okay, let's try with 2 decks. And we have a problem. Index was outside. Why was it outside? Out. I'm sorry. Okay, that should work now. 2 decks. There we go, it works just fine. Let's try with a larger number just to make sure that it's working. Let's try 255, or maximum number. And it works. Ow. Finally, let's test for our validation. Something I should have done before. Option 1, enter number. Now let's try some string. 1 will be used instead. And over there I tried 0, you know, just empty. Oop. 1, now 0. Error, there we go. Now we know everything's working. Alright guys, once again, if you liked the video, if you liked the way that I'm programming, if you like the series, please give it a like. Don't forget that if you have any other ideas of possible implementations, leave a comment below, and I will try my best to make a video about it. Thank you for watching.